The Milky Way is the galaxy we call home, a vast island of stars drifting through the universe. On a clear night, far from city lights, you can see a faint glowing band stretching across the sky. That soft river of light is not a cloud, and it is not a distant nebula. It is a combined glow of billions of stars in the disk of our own galaxy. For ancient civilizations, this band of light was mysterious, inspiring myths and legends, but today we know it is a direct view into the structure that contains our entire solar system. The Milky Way is immense beyond ordinary imagination. It stretches about 100,000 light-years across, meaning that light itself, traveling at the fastest speed in the universe, would take 100,000 years to cross from one edge to the other. Inside this enormous system are more than 100 billion stars, along with planets, asteroids, comets, clouds of gas, and vast reservoirs of cosmic dust. These ingredients form nebulae where new stars are born and remnants where old stars have died. Our solar system is only a tiny part of this structure, located in a spiral arm known as the Orion Arm, about 26,000 light-years from the galactic center. Even though we live inside it, the Milky Way is so vast that understanding its true shape took centuries of observation. From our perspective, we cannot step outside and take a photograph. Instead, astronomers have mapped the galaxy by measuring the motion of stars, the distribution of gas, and the signals of radio waves across space. What they have discovered is extraordinary. The Milky Way is a barred spiral galaxy with sweeping arms that rotate around a dense central core. These spiral arms are filled with glowing nebulae where new stars ignite, clusters of bright young suns, and dark lanes of dust that obscure distant starlight. The galaxy is not a flat disk, but a complex structure with central bulge, a thin rotating disk, and a vast spherical halo extending far beyond the visible stars. Surrounding the Milky Way is an enormous halo of dark matter, invisible but essential, providing the gravitational framework that keeps the galaxy stable. Without this unseen mass, the stars in the outer regions would move too fast and escape into intergalactic space. The Milky Way is also ancient. It began forming more than 13 billion years ago, not long after the Big Bang itself. Over cosmic time, smaller protogalaxies merged together, building the galaxy we see today. The stars in the halo are among the oldest in existence, relics of the early universe, while the disk continues to evolve, forming new stars from gas that cycles through generations of stellar birth and death. In this way, the Milky Way is both a fossil of cosmic history and a living system still creating new light. The story of our galaxy is a story of motion. Everything inside the Milky Way is moving. The galaxy rotates, carrying stars in vast orbits around the center. Our sun itself travels at about 200 kilometers per second, completing one full orbit roughly every 230 million years. This means that since the sun was born about 4.6 billion years ago, it has circled the galaxy only about 20 times. The night sky feels eternal, but in reality, the solar system is racing through space, embedded in a galaxy that is constantly changing. The spiral arms are not rigid structures like the arms of a spinning wheel. They are more like waves of density moving through the disk, compressing gas, and triggering star formation as material passes through them. As clouds collapse into new stars, the galaxy renews itself. The Milky Way is filled with star nurseries, regions where cold molecular clouds collapse under gravity, igniting new suns. The Orion Nebula is one such nearby nursery, glowing with the light of newborn stars. But star formation is only half the cycle. Stars also die, and when they do, they return material back into the galaxy. Supernova explosions scatter heavy elements into space, enriching the interstellar medium with the atoms needed for rocky planets and life. In this sense, the Milky Way is a cosmic ecosystem, constantly recycling matter across billions of years. Every atom of carbon in your body, every atom of oxygen you breathe, was forged in stars and spread to the galaxy long before Earth existed. The Milky Way is not just where we live. It is part of what we are. The Milky Way is also filled with regions of mystery that we cannot see with our eyes alone. Much of the galaxy is hidden behind thick curtains of dust. Visible light cannot easily pass through these clouds, which is why the Milky Way appears as a glowing band rather than a clear panorama of stars. But astronomers have developed ways to look deeper. Radio telescopes can detect the faint emissions of hydrogen gas, the most abundant element in the galaxy. Infrared telescopes can pierce through dust and reveal star-forming regions buried inside molecular clouds. X-ray observatories can uncover violent environments where matter is heated to extreme temperatures near neutron stars and black holes. When we observe the Milky Way across different wavelengths, an entirely new galaxy emerges, one filled with energy, motion, and invisible structures. At the heart of the Milky Way lies one of the most extreme objects in the universe, a supermassive black hole known as Sagittarius A. It contains millions of times the mass of the Sun, compressed into a region smaller than our solar system. This black hole is not visible directly, but its presence is revealed through the motion of stars orbiting close to the galactic center. Astronomers have tracked these stellar orbits for decades, watching stars swing around an invisible point in space at tremendous speeds. Their paths provide some of the strongest evidence that a black hole truly exists at the center. Yet Sagittarius A is not alone. The galactic center is crowded with dense star clusters, turbulent gas clouds, and intense radiation. It is one of the most energetic environments in the Milky Way, a region where gravity dominates and where the history of the galaxy is written in the motions of countless stars. Beyond the center, the Milky Way's spiral arms stretch outward like luminous rivers. These arms are filled with nebulae, regions where gas collapses into new stars. Some of these stars are massive and short-lived, shining blue and bright before exploding as supernovae. Their deaths inject energy into the galaxy, shaping the interstellar medium and influencing future generations of star formation. In the disk of the Milky Way, stars come in many varieties. Small red dwarfs that burn slowly for trillions of years, sun-like stars that provide stable light for billions, and giant stars that live fast and die young. The diversity of stars means a galaxy is filled with countless different planetary systems, many of which may contain worlds unlike anything in our solar system. The Milky Way also contains star clusters, groups of stars born together from the same cloud. Open clusters sparkle in the spiral arms, while ancient globular clusters orbit in the halo, containing some of the oldest stars in the galaxy. These globular clusters are relics of the early Milky Way, survivors from a time when the galaxy was still forming. Surrounding the visible disk is a galactic halo, a vast spherical region filled with old stars and dark matter. The halo extends far beyond the disk, reaching hundreds of thousands of light years into space. It is in this halo that astronomers find evidence of the Milky Way's violent past. Streams of stars arc across the sky, remnants of smaller galaxies that were torn apart and absorbed by our own. The Milky Way has grown through mergers, consuming dwarf galaxies over billions of years. Even today, it continues this process. The Sagittarius dwarf galaxy is currently being stretched and devoured, its stars becoming part of the Milky Way's halo. Our galaxy is not an isolated island. It is part of a larger community known as the local group, which includes dozens of galaxies bound together by gravity. The largest neighbor is the Andromeda Galaxy, a majestic spiral galaxy similar in size to the Milky Way. Andromeda is moving toward us at about 100 kilometers per second. In about 4 billion years, the Milky Way and Andromeda will collide and merge, reshaping both galaxies into a new cosmic form. Despite the word collision, individual stars are so far apart that direct impacts are unlikely. Instead, gravity will distort the galaxies, flinging stars into new orbits, triggering bursts of star formation as gas clouds collide. The night sky of the distant future will be transformed, filled with the bright spread of Andromeda across the heavens. Over time, the two galaxies will settle into a single massive elliptical galaxy, a new home for countless stars. This reminds us that galaxies are not permanent structures. They evolve, interact, and transform over cosmic time. The Milky Way itself is a dynamic system, shaped by gravity, mergers, star birth, and stellar death. And within it, on a small planet orbiting an ordinary star, we are looking outward, trying to understand the greater structure that holds us all.